So today's video is about Avogadro's number. But before we can talk about Avogadro's number and what it's used for, we have to talk about something called atomic mass units. So remember in atomic structure quite a few chapters ago, we talked about AMUs or atomic mass units. One proton weighs 1 AMU, one neutron weighs 1 AMU, and an electron you need about 1,800 of them to make 1 AMU. Well, atomic mass units are like imaginary. You can't weigh them. But let's look at carbon. Because remember, 1 AMU is 1/12 the mass of carbon-12. So here, right here, 12, atomic mass of 12, that's AMUs, atomic mass units. But like I said, we can't weigh atomic mass units. So Avogadro, 1780 or something like that, he didn't come up with his number. He came up with this theory about gases. And he said, if you have equal volumes of two different gases at the same pressure and the same temperature, chances are they're going to have the same number of particles. And that started everything. So Avogadro's number really didn't come from Avogadro, but they gave it to him. So, what the big deal about Avogadro's number? It's a crazy number. Avogadro's number is this. So, Avogadro's number is 6.02 times 10 to the 23rd, and it's atoms or molecules or compounds or ions or electrons, something incredibly small. Now you remember that we use a dozen for like eggs because you just don't want to buy one egg. Well, for this, we don't want to keep on saying, oh, I have 6.02 times 10 to the 23rd atoms or molecules, or I have Avogadro's number. So 6.02 times 10 to the 23rd atoms equals 1 mole. Now, 1 mole, or just the mole, is a unit. And this number, if you had a mole of, let's say, pennies, it would cover the Earth's surface almost as tall as the Empire State Building. Okay? About over 1,000 feet tall. So that would be that, or donut holes would cover the Earth 5 miles deep in donut holes. So this number is out of control big. Okay? But something incredibly interesting about that crazy number. Why that number? When we use that number of atoms for any element, now watch, remember that 12 was AMUs, atomic mass units, and we can't weigh AMUs. But when we have 1 mole of carbon atoms, or when we have 6.02 times 10 to the 23rd carbon atoms, that 12 AMU, instead of saying atomic mass units, now it's gram atomic mass. So now the cool part about using Avogadro's number is if you have 1 mole of any atoms of any of these elements, you transpose that 12 AMUs to 12 grams. Now we can weigh it. So 1 mole of atoms of any element would weigh the atomic mass in grams. So like, let's go aluminum. Aluminum weighs a rounded 27 AMUs. But if I had 1 mole of aluminum atoms, it would weigh 27 grams, not 27 AMUs. Okay? Super cool. So now we know that 1 mole of atoms of any element is their weight in grams. So it's called gram atomic mass now, but I prefer to call it the molar mass. So the molar mass, so what if we said, what is the molar mass of magnesium? Well, the molar mass of magnesium, which means 1 mole of atoms of magnesium, or 6.02 times 10^23 atoms of magnesium, the molar mass of 1 mole of magnesium would be 24 grams. All right? Now, that's pretty cool. Now, watch. These are the numbers you really have to know. Now remember, I'm not going to put a unit there. It could be atoms or electrons or whatever. But 1 mole is 6.02 times 10^23. These are really important numbers for you to know. So a half a mole is 3.01 times 10^23. A fourth of a mole is 1.5 times 10^23. And the cool thing about this number, if you know your multiples of 6, you got it. So 2 moles. There's 2 ways to express 2 moles. 2 moles, it's just 2 times 6 is 12. So it would be like this. But you know, in scientific notation, that's incorrect, because for scientific notation, you need a 1 whole number to the left of the decimal point. So you can use 12.04 times 10^23, or you can use this. You can use 1.2 times 10^24. Okay? These numbers are important to know. All right, so let's go over a few things. But now you understand we can't work with a dozen atoms because they're way too small. We should work with a mole of atoms. Now, watch. All right, so what we're going to do is we're going to do a couple problems. And let's start out with neon. Look at 20 AMUs is the atomic mass of neon. But if I had 1 mole of neon atoms, that 20 AMUs, like we said before, turns into 20 grams of neon. All right, so let's remember, 20 grams of neon is 1 mole. So 1 mole of neon equals 20 grams. Now, the other interesting part is we have to remember that 6.02 times 10^23 atoms is 1 mole. So it equals 6.02 times 10 to the 23rd atoms. Now, neon is a gas. And let's go back to what Avogadro said. Avogadro was working with gases. And now here's the deal. 1 mole of any gas, which means 6.02 times 10^23 atoms of any gas under standard temperature and standard pressure equals this. Equals 22.4 liters. All right? 1 mole of any gas at STP has a volume of 22.4 liters and has 6.02 times 10 to the 23rd atoms or molecules. Now, watch how all this fits in. What if I told you I only had 10 grams of neon? Well, if I only had 10 grams of neon and wanted to figure out everything about it, I know that neon weighs 20. So if I give you a gram number and want to find out how many moles, now listen to this, you divide the given by the molar mass. So the molar mass of neon is 20. So what would I do? I would go 10 divided by 20, and we know that that equals a half. So we got equals 0.5 moles. So it would be 0.5 moles of neon. Well, how many atoms would that be? Well, 0.5 moles of neons would be 3.01 times 10 to the 23rd atoms. And then, how many liters would half a mole of any gas give us? Well, if 1 mole gives us 22.4 liters, well, then half a mole would give us this. So, you can pick any one of these numbers and you can find all the rest out. So I started up with 10 grams of neon, that's half a mole, that's 3.01 times 10 23rd atoms, that's 11.2 liters. So now let's go to something else. Now watch. I give you 5.6 liters of NaOH. And you're going 5.6 liters. Well, you know that 1 mole gives us 22.4. So to find moles, I take what's given, 5.6, and I would always divide it by 22.4 liters. And 5.6 divided by 22.4 equals 0.25 moles. So remember, if I give you liters and want to get into moles, I got to divide by 22.4. That's an easy one. Now, so 5.6 liters of NaOH divided by 22.4 will give you 0.25 moles. Now, if I wanted to find out how many grams that would be, well, I have to find the molar mass of NaOH. So, Na, 23 plus 16 plus 1, and that equals 40. So the molar mass, or how many grams in 1 mole of NaOH, is 40. But I only have 0.25 moles. So what I would do is this. 0.25 moles. And I want to get into grams. So look, I want to get out of moles. Whatever unit you want to get out of, you got to put on the bottom. So I'm going to put 1 mole on the bottom. And I want to get into grams. Well, what's equal in grams to 1 mole of NaOH? 40. So look what happens. My moles cancel out, and it would be 0.25 times 40, which is 10 grams. So that's how you can figure out how many moles and then how many grams. Now, if you want to figure out how many formulas or how many molecules of NaOH would be in 0.25 moles, all you have to do is this. 0.25 moles times blank equals blank molecules. So I want to get out of moles again and put 1 mole on the bottom. I want to get into molecules. 6.02 times 10 to the 23rd, and that's molecules. So now I cancel moles, I cancel moles. Now in your calculators, it's pretty neat, because what you can do is you can put 0.25, then times 6.02, and then if you hit the EE button, that means times 10, and then 23. So once again, 0.25 times 6.02, EE 23. And then what you have is you're going to find out that this is what it looks like in your calculator. it's not going to say 1.5 times 10 to the 23rd. It will say this in your calculator. 1.5 E 23. And that E stands for times 10. So that's how you figure out how many molecules, how many grams, and how many moles. All right, let's do another one. Let us say we have this. So I give you 12.04 times 10 to the 23rd molecules of CO2. The first thing we're going to figure out is how many moles would that be? Well, if you know your multiples of 6, you could go like this. You would divide 12.04 times 10 to the 23rd by 6.02 times 10 to the 23rd. Now, remember, if the power on top is the same as the power on the bottom, they get canceled out. So now it's simply 12 divided by 6. So 12.04 times 10 to the 23rd molecules of CO2 is 2 moles. All right, we got 2 moles. Now if we wanted to find out how many grams that would be, you go like this. 2 moles of CO2 I want to get out of moles. Whatever you want to get out of goes on the bottom, so we're going to put 1 mole down there. Then you got to find the molar mass of CO2. Well, I got 12 and I got 32, so the molar mass of CO2 is 44 grams. So, moles cancel with moles. 2 times 44, 88 grams will be in 2 moles of CO2. Now let's see how many liters that would be. So all I do is this again, 2 moles of CO2, and then it'll be times blank equals blank liters. I want to get out of moles. Whatever you want to get out of goes on the bottom, 1 mole. Whatever you want to get into goes on top. 1 mole is equal to 22.4 liters. So, moles cancels out with moles. 2 times 22.4, that's 44.8 liters. 44.8 liters would be your answer. So, my rule is when in doubt, always convert to moles. You've got 3 things. If I give you grams, then you find and divide by the molar mass. If I give you liters, you divide by 22.4. If I give you molecules or atoms, you divide by 6.02 times 10 to the 23rd. Remember, that's defined moles. If I give you moles and want to find grams, if I give you moles, then your fraction will be mole on the bottom, and then your molar mass multiplied by how many moles. If I give you moles and want to get into liters, it would be moles times 22.4. If I give you moles and want to get into molecules or atoms, it would be moles times 6.02 times 10 to the 23rd. Okay? So this is just a start on how to use Avogadro's number. And remember Avogadro's number, 6.02 times 10 to the 23rd. And remember the best thing about Avogadro's number, if you have 1 mole of atoms of any element in here, instead of saying nickel weighs 59 atomic mass units, now you can say nickel weighs 59 grams. Instead of AMU, atomic mass units, now they're gram atomic mass. Okay? All right. Next video will be on some equations with Avogadro's number.